Hello, good day viewers. Still on how to graph rational functions. Sometimes a rational function may contain more than one vertical asymptote, and that is what we are going to consider in this tutorial. We have our function y equal to x divided by x squared minus 9, and we want to see the behavior of the graph of this function. As always, we are going to start by finding the vertical asymptote, and that can be attained by setting the denominator equal to 0. Our denominator is x squared minus 9, and we're going to set it equal to 0. X squared is equal to 9 if negative 9 crosses over. And finally, you can see that x is equal to plus or minus 3 if you take the square root of both sides. So at x equal to plus or minus 3, we have our vertical asymptote. So x equal to plus or minus 3. And now to find the horizontal asymptote, we are going to consider the degree of our numerator and the denominator. You can see the degree of the denominator is higher because we have 2 here, and that of the numerator is 1. You can see 2 is greater than 1. And whenever we have a situation like this, we consider y equal to 0 as our horizontal asymptote. And you can also evaluate the function as the limit of x approaches 0, yet you're going to obtain y equal to 0. Then for y and x-intercept, let me start with y-intercept. When x is 0, what is going to be the value of y? If x is 0, you can see everywhere we have 0 divided by negative 9, which is still 0. Y will definitely be equal to 0. And for x-intercept, what is going to be the value of x when y is 0? When y is 0, our numerator will be equal to 0, and hence x will also be equal to 0. For the domain and the range, let us construct the graph first. So we need these 3 information as a key. Let's start plugging vertical asymptote and horizontal asymptote. So here is our graph. Our vertical asymptote is at x equal to negative 3 and x equal to positive 3. All right, this is our vertical asymptote. And for the horizontal asymptote, remember it is at y equal to 0, exactly on x-axis. Okay, this is all about asymptotes. Now let us start plugging our points. We have x and y-intercept as 0, 0. So our first point will be exactly at the center here. So we are going to test some values to the left, the center, and to the right. Let me start to the right. To the right, we can only test values greater than 3. So I think we can test 3.5 somewhere here. If x equal to 3.5, what is going to be the value of y? Our function, remember, is y equal to x divided by x squared minus 9. So if x is 3.5, we have 3.5 divided by 3.5 squared, which is 12.25 minus 9, 3.25. And 3.5 divided by 3.25 is approximately equal to 1.1. So when x is 3.5, y is 1.1. So we have 1.1 somewhere here. So when x is 4, let's test that. We have 4 divided by 4 squared is 16, then 16 minus 9 is 7. We have 4 divided by 7, and 4 divided by 7 is approximately 0.6. We have 0.6. So when x is 4, y is 0.6. This is 4.6 is somewhere here. Now we can test for 5. We have 5 divided by 5 squared is 25, and 25 minus 9 is 16. And 5 divided by 16 is approximately equal to 0.3. So when x is 5, y is 0.3, approximately. 0.3, we have something like this. So let me test. I can even test 8. Remember that the curve can go closer and closer to x-axis, but it will never touch that axis. So let me test for 8. We have 8 divided by 8 times 8 is 64, and 64 minus 9 is 55. And 8 divided by 55 is approximately 0.1. You see, it can go closer and closer, but it will never hit 0. So we have a point somewhere here. So I think I can construct the graph. It is going to be in this form. All right, something like this. So now let us test some points to the left-hand side. All of these points are going to be negative values of x. Remember that we are going to test for values less than -3. And without wasting our time, let me tell you, they are going to be symmetrical to these points. Just that all the points to the left are going to be the negative values of y to the right. So our graph is going to be like this. So let us just copy the points. So for -3.5 somewhere here, it is going to be 1.1 negative. So we're going to have a point right here. Remember, when x was +4, our point was 0.6, so we are going to obtain -0.6. So -0.6 is going to be somewhere here. And when x was +5, remember we obtained the value of y to be approximately 0.3. So we're going to get -0.3 somewhere here. And remember, I choose 8 when y was 1.1 approximately. So we're going to obtain a point somewhere here. All right, so I can construct the graph. All right, something like this. So all we have to do next is to test some values at the center. All right, let me test for when x is -2.5. This will be -2.5 divided by -2.5 squared is 6.25, minus 9 is -2.75. And 2.5 divided by 2.75 is approximately 0.9. So when x is -2.5, y is going to be 0.9. And 0.9 is somewhere here. Okay, now we can test for -2. This is equal to -2 divided by -2 squared is 4, and 4 minus 9 is -5. Negative cancel. 2 divided by 5 is equal to 0.4. So when x is -2, y is 0.4. We have 0.4 somewhere here. Let me test for -1. We have -1 divided by -1 squared is 1. 1 minus 9 is -8. Negative cancel. 1 divided by 8 is approximately 0.1. So we have a point closer, just above -1. Already we have seen that when x is 0, y is 0. So we can test for other values of x greater than 0 somewhere here. So without testing these values, I want you to understand that all the points here are going to be just a mirror image of these points, but towards negative direction. So we have a point here. We have another point here. We have a point right here. So our graph is going to look like this. Let me construct it. All right, this is exactly how our graph is going to look like. Now, all we have to obtain are the domain and the range. Let me start with domain. Domain, we have the values of x from negative infinity down to positive infinity, excluding negative 3 and positive 3. So domain, remember they are the values of x from negative infinity down to negative 3, excluding negative 3. Then from that negative 3 down to positive 3, and from positive 3 down to positive infinity. Then for the range, which are the values of y, if you observe carefully, y satisfy every real value. So every real value you test, it will satisfy y on this graph. Therefore, we say that y is a set of values from negative infinity down to positive infinity, or you say y belongs to the set of real numbers. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.